we need relative motion, right? We need relative motion whenever there are like many objects, more than one object doing motions simultaneously. We need relative motion, then we can easily describe the motion of those objects. That's why we need relative motion. So mostly we are talking about two objects here. When two objects has a relative motion, I mean when they move simultaneously, you can think about a relative motion between those two objects. Then those problems gets easier, right? So whenever there are two or more objects moving, you always have to think about the relative motion. Then those kind of problems will be easier, right? That's why I need you to uh, learn this. Okay, right? Take down the topic relative motion. You can use the chat box if you have any problems regarding that. Okay. Whenever we talk about relative motion, there's a basic equation, this equation, right? I think everyone has seen this equation. VAB. What does this mean? Relative to B, velocity of A. Relative to B, velocity of A. So to find that, you just have to insert a third object in between those. So here I am putting earth here, right? Earth or ground here. So you can separate this term into like this, VAE plus VEB. Yeah, with respect to B, respect to all, we can say respect to as well, or else we can say relative to B. So you can see E is applied like this, right? So you have to remember, this is the basic equation for relative motion. You can just put a E in between. So E is between those two. So you should be able to explain what's happening here. Relative to B, velocity of A, or respect to B, velocity of A is equal to respect to Earth, or relative to Earth, velocity of A. Here, relative to B, velocity of Earth. So that sentence you have to clearly understand, right? Relative to this one, velocity of A. So that's what it means. Okay, right. Then the another equation is, let's say you have EB. So this EB is equal to, you can put minus here and change these letters to BE. You can change these letters to BE and put a minus there. Right? So it is a vector thing, right? It is similar to a vector. You can put a minus here and change these letters. Then I'm going to apply this thing here to VEB. I'm putting minus VBE. So we can modify this equation like this. VAE, instead of EB, I am putting minus BE. So you can modify this equation like this. So according to this equation, what does it say? Relative velocity between two objects is equal to difference of those velocities. This is the difference of velocities, right? These are Earth relative velocities. Okay. Okay, take this down. Take this down. Correct? Yeah. So you don't have to think too much about it. When you have vector EB, you can change the letters. You can switch the letters, right, to BE, and you can put a minus there. It is a vector thing, right? Let's say you have vector AB to this side. And if you change the letters, what do you get? What do you get? You have to put a minus here. Then those two is equal, same. AB is equal to BA, but you have to put a minus here. Meaning of that is the direction is switched. Direction is changed. But in order to make it equal, you have to put a minus there. Same thing here. From relative to B, velocity of E is equal to minus relative to E, velocity of B. You have switch. So these are basic equations, right? So everything regarding relative velocity is derived using these two equations. So whenever you have problems, you can use these two equations in order to derive anything in relative velocity. So you have to remember these two equations. So you can easily remember them, right? This is like this. So we have VEB here. So instead of VEB, you can put what? Minus VBE. Because they are the same, right? Are you sure? Okay. Another thing is when we are doing relative motion questions, we are not going to use this all the time, right? We are not going to use this equation all the time. We will have some shortcut methods whenever you get a relative motion question. So that is what we are going to do next. Okay. So the first application of this whole thing, when moving to same side. When two objects are moving to the same side, we have to get an expression for the relative velocity between those two. Let's say object A is moving to this side at V1. Object B is moving to this side at V2. So same side, right? Same side. So when they say just velocity, it means without saying relative to something, just velocity, it means it is always relative to Earth. So they are not mentioning Earth, right? So this V1 is what? Velocity of A relative to Earth. This V2, velocity of B relative to Earth. Velocity of B relative to Earth. So that is what V1 and V2 means. Then we need to find velocity of A relative to B. So I'm going to use this equation. Same equation as this, right? I'm going to use this equation. So what is VAE? VA is to this side V1 minus, then we have VBE. What is that? V2. Since these two vectors are to the same side, what can you do? You can simplify these two. Then what do you get for the relative velocity VAB? V1 minus V2. You get V1 minus V2. So what does this mean? When the objects are moving to the same side, you just have to subtract the velocities. Take it down. Take this down, right? You will understand when we are doing questions, okay? Clearly you will understand further. Just take this down. Thumbs up if you have done taking. Taking it down, right? Got it? Okay. Under this, right, put an asterisk mark and write. Yeah, E represents Earth, yeah. E is Earth, right? E is Earth. It doesn't necessarily have to be Earth, but here I'm using Earth, okay? It can be any other objects. We'll see when we are doing problems. Here E means Earth. So VAB is V1 minus V2 to this side, okay? Under this, right, when two objects are moving, to the same side, relative velocity between them is their difference of Earth relative velocities. Their difference of Earth relative velocities. Difference of Earth relative velocities. Okay. So when you are doing MCQs, so that's what you have to do, right? If the objects are moving to the same side, let's say one objects move 5 meters per second, another 10 meters per second. What's the relative velocity between them? One is moving 5 meters per second, another one is moving 10 meters per second. You can take a relative velocity at once, so that just subtract those two, right? What do you get? 10 minus, 5 meters per second. 5 meters per second. Then that is the magnitude of relative velocity. After you get that, then you can think about the direction of the relative velocity. So that's what we are going to do in these questions. Okay. So when the objects are moving to the same side, you just have to subtract velocity values. Okay, then let's see what happens when objects are moving to opposite directions. Moving to opposite directions. Let's say object A is moving to this side, V1. Object B is moving to this side, V2. Then to this scenario, I'm going to apply this equation. I need to find relative velocity between these two. What is VAE? VA is relative to Earth velocity of A is to this side, V1. Then we have a minus here. VBE. You have to substitute with the direction, right? Relative velocity of B, velocity of B relative to Earth is to this side. Okay. Then we have to simplify these two. So these are vectors, right? And they are to different directions. You cannot simplify these because they are to different direction. So you have to make all these to one direction. I'll keep V1 here and I can flip this arrow. But when you flip that arrow, it causes a negative sign. You have to apply a negative sign and flip the arrow. Okay? You can flip the arrow, but you have to put a negative sign. Understood, right? So that's what we do when we are doing vector calculations. Whenever you flip the arrow, but you have to put a negative sign in front of that. Negative in front of that. Now you can see both vectors are to the same direction. Then you can simplify these. What do you get? V1 plus minus minus plus V2 to the S side. So what do you get? V1 plus V2 to this side. So when the objects are moving to opposite directions, you just have to add those velocities in order to get the relative velocity between them. Okay, take it down. And thumbs up once you take it down. Yeah, for the I'm going to explain that as well. Taking it down, thumbs up, right? Right. Under this, right, put an asterisk mark and write when the objects are moving, to opposite directions, relative velocity between them is the sum of their earth relative velocities. Is the sum of their earth relative velocities. Sum means SUM sum, right? So that opposite directions means towards also is opposite directions. This we call towards, right? Towards each other. Okay. When objects are moving to opposite directions, when objects are moving to opposite directions, relative velocity between them is the sum of earth relative velocities is the sum of earth relative velocities. Yeah, opposite opposite direction means this one, right? Opposite means towards also is opposite. Okay, towards also is opposite. Let's say objects are moving like this. This is away. Away also is opposite directions, right? For both cases, you just have to add their velocities. For this one and for this one, in order to get the relative velocity, you need to add those velocities, v1 plus v2. Moving to the same direction, you need to subtract. That's all you have to remember, right? Move into opposite directions, you have to add the relative velocity, add the velocities. If they are moving to the same direction, you need to subtract velocities. So that's the only scenario there. Okay? If you want, you can take this down. But these are earth relative velocities, right? v1, v2 are earth relative velocities. So this is derived using the previous basic equations, right? But when we are doing questions, we are not going to derive this all the time. You just have to apply this for MCQs basically, right? For MCQs. Everyone got that, right? Okay, try the first question. I'll explain that. Before that, just try that first question. So when we are doing questions, it will be clear, right? If you got the answers, please you can send the answer. Try the first question. Just put just a try. If you can get the answer, send me that in the chat box. Right. Let's understand the question, right? Maximum relative velocity. Maximum relative velocity between two objects is 100 meters per second. Minimum velocity, relative velocity is 20 meters per second. Their velocities are. Their velocities are. What does it mean? When they say just velocities, they are asking about Earth relative velocities, right? Relative to Earth. In earlier lessons, when we are doing linear motion equations, we didn't think about relative to anything, right? They just say velocity. Because all those velocities are relative to Earth. All those velocities are relative to Earth. So we don't, when we say just velocity, specifically without saying anything respect to, you have to remember those velocities are relative to Earth. Okay? So they are asking their velocities, meaning Earth relative velocities. Right. So in the first part, we have maximum velocity. When do we get a maximum velocity? Velocities can be added or subtracted. So maximum velocity is gained when we add those velocities, right? If they are moving towards or away, meaning to opposite directions, you get the maximum relative velocity between those between two objects, right? You can understand this. Let's say you are moving on a bus and there's a bus in front of you also moving towards you. What do you see? That second bus, speed of that second bus, you notice that it has a higher speed relative to you. That bus has a higher speed. So it is to get the maximum velocity, you just have to add the velocities. So the relative velocity is v1 plus v2 and they have given a value that is 100. Minimum relative velocity is gained when the objects are moving to the same side. Let's say you are moving on a bus and there's a bus, another bus beside you, passing you, right? Do you notice that the second bus is having a less velocity, right? The reason is you are seeing relative to you. The speed of the second bus you are noticing relative to you. So you have to subtract the velocity of your bus. Then you notice the minimum velocity in that case. So the minimum velocity is noticed when they are moving to the same direction, like this. So the minimum velocity should be v1 minus v2. They have given a value as 20. Then those are two simultaneous equations. Simplify these two, then you can get the answer. If you have any problem, please send me in the chat box, okay? So this is first simultaneous, second simultaneous. You can add those two. V2 cancels off. You get 2v1 equals 120. So v1 is 60 meters per second. Then you can subtract these two equations. V1 cancels off. You get 2v2 equals 80. So v2 is equal to 40 meters per second. Yeah, the answer is 40 meters per second and 60 meters per second. Fourth one is the answer, correct. You can take this down. Did everyone get that? If you have no problems, thumbs up, okay? Okay, then everyone try second problem. It is a similar problem. Try the second problem. And send me the answer in the chat box. I'm not going to. It is a similar one, right? Send me the answer in the chat box. I think there's a problem with that one, right? The answer is not given there. Second part. Right, we'll see. Maximum relative velocity is 70, meaning you have to add the earth velocities, that is 70. Minimum relative velocity is 10. So you have to subtract this. So maximum relative velocity 70, minimum is 10. Then you just have to simplify these two. When you add these two, you get 2v1 equals 80. So v1 is 40. Then subtract these two, you get 2v2 equals 60. v2 equals 30. So the answer should be 40 and 30, but it is not given, right? The answer should be 40 kilometers per hour and 30 kilometers per hour. The answer is not given. Yeah, it is in kilometers per hour, right? There's a mistake with the question. No, the answer should be in kilometers per hour. There's a mistake in the question, right? Kilometers per hour. It should be 30 and 40. 30 and 40, okay? Right. Then you can try third question. You can try third question. Right. Okay. Right. Let's see how to do this. So this is a different type of questions, right? Different types of questions. When two objects A and B move towards each other. Let's say these are the objects A and B. They are moving towards each other. Let's say at V1 and V2. Okay. What do they say? They get close 5 meters per second. I mean 5 meters in each second, every second. That thing you need to understand. Their combined, their gap is decreasing at a rate 5 meters per second. So that you have to understand that 5 meters per second is the relative velocity between them. That's what you have to understand. So what's the relative velocity? In terms of V1 and V2, it is V1 plus V2. So that is equal to 5. So that what it means, right? And at the another part, they say when they are moving to the same side, same side, their gap is getting close 1 meters per second. Meaning V1 minus V2 is 1. So the another thing you have to understand is rate of change of velocity, rate of change of gap, sorry, not velocity, rate of change of gap. The gap is changing between objects, meaning it is the relative velocity between those two objects. Got it? Then you just have to simplify this. Add these two, you get 2v1, 6. So v1 is 3 meters per second. Then subtract 2v2 is equal to 6. v2 is 4. So v2 is, so you get 3 meters per second and 2 meters per second. Third answer, yeah, correct. Third answer, okay. Those who didn't get it, you can do this one. Then try fourth question and send me the answers. That is a similar question. Fourth one. Right, let's see. A and B move towards each other, meaning you have to take the sum of those velocities to get the relative velocity, and it is equal to 4. Then at the another part, moving to the same direction, they get closer by 1 meters per second. So it is should be the difference. So that is 1. Then you can subtract or add. If you add these two, you get 2v1 equals 5. So v1 is 2.5 meters per second. Then subtract these two, you get 2v2 equals 3. v2 is 1.5 meters per second. Yeah, the correct answer is second one, okay? Correct answer is second one. So in these questions, to get the relative velocity, you just had to add the velocities, so subtract velocities. That's all you had to do. But to do that, you need to remember that these velocities are Earth relative velocities, right? Not relative to anything else. These velocities, all velocities are Earth relative velocities. Then you can just add or subtract in order to get the relative velocity. For other cases, you have to go for the fundamental equation, right? That fundamental equation we did earlier. When velocities are not directly relative to Earth, you have to go for the fundamental equation. We'll see when we are doing questions. So in this type of questions, what do we have to understand? When they say gap is decreasing at 4 meters per second, meaning every second their gap has decreased by 4 meters. Since they are closing, right? Since they are closing towards, their gap is decreasing. Every second it is decreased by 4 meters. Right? Meaning of that is relative velocity between them. So that is a change of gap. Rate of change of gap also can be considered as relative velocity between two objects. Rate of change of gap can be considered as relative velocity between two objects. Under this one, put an asterisk mark and write this sentence. Write down rate of change of velocity, rate of change of gap, gap, rate of change of gap is equal to, rate of change of gap is equal to relative velocity between two objects. Rate of change of gap is equal to relative velocity between two objects. Got it right? Understood? So that is the second type of questions you might get. Right. Then there's the another type. Before moving to that, you can just try that, right? Try that. And if you can send me the answer, you can send me the answer. I'll explain that. Fifth question. Try that. Right. So in the fifth question, now listen. Fifth question. Two men move to opposite directions at 2 meters per second, 6 meters per second, starting from the same place. When their gap is 12 meters, time passed is. Okay. So let's say A and B men. So one man is A, another man is B. Starts moving, starting from the same place. They are moving away, right? And those velocities are given. One is 2 meters per second, another one is 6 meters per second. Okay. One is 2 meters per second, another one is 6 meters per second. So these are easy questions, right? First thing is you need to think about the relative velocity between these. So what's the relative velocity? 2 and 6 move into opposite directions. Relative velocity is 8, right? 2 plus 6. Yeah, relative velocity is 8. Okay, you found the relative velocity. What we need to find? You need to get time. So to get the time, you need to divide distance by velocity. Here actually relative velocity. What do you get? 3 over 2. You get 1.5 seconds. Got it? So you get 1.5 seconds. Third answer. Yeah, correct. Third answer. So once you get, so this is all you have to do. You can actually do it without even writing anything, right? But if you do a simple calculation, then these problems are complicated problems. But using relative motion, these problems gets very easy. Okay. So this is all you have to do to solve that problem, solve these problems. Let's see actually what happens. So in MCQ, you can do this, right? Yeah. 12 meters is the gap between them, 12 meters. Then you just have to divide that by relative velocity between those two. Then you can find the time. I am just saying that, right? I'll make you understand why do we do that. Now listen carefully, right? So once you understand that, you can at once do this when you get a MCQ regarding that. But this is what happens, right? So when Earth's frame, this is happening, right? So you are sitting on the Earth's frame. You are on the Earth's frame. Earth's frame means everything is relative to Earth. So this 2 meters per second, 6, everything is relative to Earth here, right? When you are on the Earth's frame, everything must be relative to Earth. So these are relative to Earth. Then after a while, what happens? Their gap increases. The gap is 12 meters. Gap has increased to 12 meters. What they ask is for the time. You can simplify this problem sitting on the Earth's frame as well. When you consider the Earth's frame, there are two objects moving. Listen carefully, right? There are two objects are moving simultaneously. It is a somewhat complicated to think about two objects at once. It is complicated to think about two objects at once. Okay? If you are staying on the Earth's frame, these two are moving. Okay? Therefore, I am going to go to a different frame. Different frame, right? I am going to move to the B's frame. So when you are on the B's frame, everything in the B's frame should be relative to B. Okay? So first you have to find the velocity of A relative to B. So what do you get for the velocity of A relative to B? Relative to B means you can think like B has stopped. Obviously both A and B are moving, right? Both A and B are moving. But if you are on the B's frame, you can consider that B is stopped. B is stopped. Just directly think that B is stopped, right? B is stopped. So what do you get for the relative velocity? VAB. You just have to add these two. 2 plus 6. You get 8. What's the direction of 8? If B is stopped, what do you see? That A is moving away. If B is stopped, you notice that A is moving away, right? So the relative velocity should be to this side, to this side. Actual direction is not relevant to this question. Okay. Now velocity is relative to B. Relative to B, velocity of A is 8. I'll draw this one, right? Now the B velocity of B is stopped. This is B's frame, right? Velocity of B is 0. So relative to B, what's the velocity of A? Velocity of A is 8. And their gap becomes 12 meters. So you are solving these problems regarding the B's frame. Understood that? B is stopped, right? B is stopped. If B is at the same place, only A does the whole 12-meter distance, right? So the relative to B, displacement done by A is 12 meters. Because B does not do any displacement now. B is just stopped, right? B is at the same place because you are thinking about B's frame. Okay? I think you understand this. So now you can just put this equation S equals ut to this frame. Now think that all these terms are relative to B, right? So relative to B, what is S? Only A moves a 12-meter distance. Here you need to have the relative to B velocity. That is 8. And time. Then you can find the time. 12 divided by 8. 3, 2. So it is 1.5 seconds. This is B's frame. Take these two down, right? These first questions I'll just explain a bit further. Then we can quickly move on, go through, right? Just take these two. This is Earth's frame, then this is B's frame. Take these two. Which method are you referring? This method? Yeah, that T equals d over V also, they are the same method, right? You just directly apply T equals d over V to that problem. Here what I explained is what's the reason for applying that? What's the reason? You just applied that without a reason. So this is the reason, right? So these B's frames, those ones, you should be able to write, right? For an MCQ, you don't have to think this too much, right? Just apply d divided by relative velocity between them. But there you don't understand clearly what's happening. Here you understand what's happening there. So then say A's frame. First take this down and thumbs up if you have taken it down. So this is B's frame, then you have A's frame. Thumbs up, right? Right. Now let's consider the A frame, right? So in the frame of A, everything should be relative to A. Relative to A means A is stopped. A is stopped. As if A is stopped, how do you see the remaining objects? Right? So what if A is stopped? A is moving to this side, B is moving to this side. But here you have to consider A is stopped. In order to make A stop, you need to get velocity of B relative to A. Relative to A velocity of B. What do you get? Since the objects are moving to opposite directions, you just have to add these two, right? Here also add these two. 8 meters per second. What's the direction? If A is stopped, velocity of B should be what? To which direction? To this direction or to this direction? If A is stopped, what is observed by A? A observes that B is moving away, right? So that's the relative velocity. So relative to B, relative to A, velocity of B is A to this side. Got it? Now we have the A relative B, velocity of B relative to A. I'll just draw that. So you have A here. This is A frame, right? A is at rest. If A is at rest, velocity of B is what? To this side, 8 meters per second. To this side, velocity of B is 8 meters per second. A is stopped. And the gap becomes 12 meters. All these 12-meter gap displacement is done only by B. Because A is stopped, right? Both are not moving. Then you just have to apply this equation. You get the same answer there. S is 12. Now U is relative velocity 8, then time. So T is 12 over 8, which is 1.5 seconds. So the time is same for all these three. So this frame thing you should be able to do, right? So what's the advantage of using this? The advantage of this is when two objects are moving simultaneously, it is difficult to think about both at once. Advantage here is you can stop one of the object. You can stop one of the object and think about the another one's moving. So here we have stopped A. Then you have to think about motion of B only. Then it is easy. Then it is just a S equal UT question. Understood, right? Okay, A's frame, take it down. So these are three different ways you can do the same problem. Just take it down. If you have any problem, send me. Once you take it down, thumbs up, okay? Got it? Thumbs up, right? If you have taken it down. Right. Under this, write down advantage of using relative velocity is that you can stop one of the object. You can stop one of the objects you can stop one of the object and only think about the motion of other objects. Right. Then try a six question and send me the answer. You can directly get the answer, right? But you have to understand what's happening there. What's happening, right? You have to have that comprehension. What's happening there? You can just take the answer, but you have to understand the concept. What you are doing actually there. That's the theory, right? You have to understand the theory as well, so you can do any type of question. Try six question. Right. So they say use ATN 2.5 meters. Okay, right. Right. Now listen, right? So A and B main 2 meters per second, 6 meters per second. So this is happening in Earth's frame. I am thinking about A's frame. Here all you have to do is just add these two velocities and multiply by 10. You get 80. Right? You get the answer there. But I'm explaining this, what's happening, why we are doing that, right? That's what I'm doing. So A's frame, I am solving this problem sitting in A's frame. So in A's frame, everything must be relative to A. So let's say relative to A, velocity of B. Relative to A means if A is stopped, you know. So since these are moving to opposite directions, you just have to add these velocities. 8 meters per second. What's the direction? Direction is not necessary, but for explanation, I'll do that. If A is stopped, what do you see? B is moving to this direction at 8 meters per second. And the displacement done by B is, because A is stopped, whole displacement has to be done by B. Okay, now A is stopped, right? A is stopped. This is A's frame. A is stopped. B is having a velocity 8 meters per second to this side. It's moving away. For how long? For 10 seconds. For 10 seconds, B is moving to this direction at 8 meters per second. So this one is called ACE frame. This image is ACE frame. Then just do S equals UT. What's the speed? 8 times 10. Then you get 80 meters. Understood? Actually, their gap becomes 80 meters after a while. Understood? Then another one. So you know that this gap is increasing, right? This gap is increasing. I'll do that question also sitting on ACE frame. When the gap is 20 meters, what's the time spent now in the second part? For that also just apply S equal UT, but everything should be relative to A. Now the gap is 20. Relative to A, gap is 20. Velocity is relative to A. It is still 8, right? Then time. So T equals 20 over 8. We have 5 fourths and 2 fourths. So 2.5 seconds. So we have to stay 2.5 seconds, take it down. And if you have problems, let me know. You should be able to draw these diagrams, right? These ones. These diagrams are called frames. ACE frame. Yeah, the second answer. Second answer. Take it down and thumbs up, right? Took it down, thumbs up. Okay, so those who did the question, you can try 7th question. 7, right? First, draw a sketch. Draw a sketch. Draw the sketch on Earth's frame. Earth's frame. Right, let's see. A cycle traveling at 1 meters per second ahead of a motorcycle. I'll say cycle, capital C, and it is moving at 1 meters per second. Then behind that, there's a motorcycle, I'll say capital M, moving at 11 meters per second. At this instant, their gap is 100 meters. At this instant, their gap is 100 meters. So this is moving slower, this is moving faster. So eventually, the motorcycle is going to pass cycle, right? So what they ask is the time it requires to pass cycle. Okay, so that's what they ask. So this is you can do this on Earth's frame as well, but it is a bit complicated to do it in Earth's frame. Why? In Earth's frame, you have to think about motion of both, right? So because of that, I'm going to think about motion of one, right? The answer is 10 seconds, right? But I need to explain what is happening here. So I'm going to consider C frame. Cyclist frame. Cyclist frame means everything should be relative to cyclist. It is as if you are on the cycle, right? Everything noticed by the cyclist. Okay, what's the velocity of cyclist? Velocity of motorcycle relative to cyclist. Now the cyclist is stopped in the cyclist frame. What's the relative velocity? Objects are moving to the same side, meaning you have to take the difference of velocities. So that is 11 minus 1, 10. Then you can think about direction. If cyclist is stopped, what is noticed by the cyclist? Is at the same place? Is the motorcycle moving away or towards the cyclist? if cyclist is stopped? Motorcycle is moving towards, right? So the relative velocity should be to this side. Got it? 10 is the relative velocity. Now the cyclist is stopped. Stopped. This is stopped. This 100-meter gap should be done by the motorcyclist only. So the relative to cyclist, motorcyclist displacement should be 100 meters. This is if cyclist is stopped, motorcycle has to do 100-meter distance. Then we know the relative to c, displacement and velocity. Then just apply s equals to t. So everything is relative to c now. So what is s? 100, u is 10, t. So t is 10 seconds. I'll take it down. So we solve the problem on sitting on C's frame. C's frame, right? So this frame thing you have to understand. These questions are not hard, right? But you need to understand these frames. Take it down and thumbs up, right? Once you take it down. You can solve the problem sitting on the motorcycle as well. But I'm not going to explain. If you want, you can draw the diagram. So this is the diagram, right? Cyclist is at rest. Motorcycle is moving towards cyclist at 10 meters per second, and their gap is 100 meters. So this is C frame. Draw this as well, and thumbs up, okay? This frame thing you have to understand, okay? Otherwise the questions are easy. No, you can do that way. At the end, that is what we did, right? That is what we did. You can do that, right? That is what you have to do. But I explained this. You don't have to think about frames and all that when you get a MCQ. But when you get an essay question regarding relative motion, you have to mention those frames, right? Which frame you are doing those for essay questions. For MCQs, you can. That is what we did, right? So what you have to do is just find the relative velocity, then just divide by distance or multiply by time. For MCQs, it is enough. You have to think, but this also you have to understand, okay? I think you understand this one. It will be useful for essay questions. You have to mention the frames in essay questions. We did the same thing, right? Same thing. Everyone, did taken it down or what? Did you take this down? Right. Then try next question, 8. 8 question. Question 8. So if the problem gets complicated, these problems are not complicated. These are very simple problems, right? If the problem gets complicated, you have to refer frames, okay? First draw is sketch. First draw the Earth's frame, right? So for MCQs, you don't have to think too much, right? You can directly get the answer if you are confident enough. Okay, this is the Earth's frame. This is the normal situation, right? A and B are moving towards each other and they meet at a point somewhere here. So what they ask is distance to meeting A. Let's say that distance is x. You can do this problem or without using relative motion as well, but here I am going to use relative motion. In order to find time, regardless of the frame, time is same for everything, right? Time is same for every frame. So to find the time, I'll stop B. You can stop A also. You can stop anything. I'll stop B. If you stop B, so meaning it is B frame. Everything should be relative to B. So velocity, relative velocity. Relative to B, velocity of A, what is that? Move into opposite directions, U plus V. If B is stopped, A has to move to this direction. Meaning like this, right? B is stopped, A has to move at U plus V velocity towards B. And their gap is S. Now just apply S equals ut. So what is S? It is just S. Velocity is U plus V. Time is T. Then you can find time, S divided by U plus V. This is the time to meet. To meet means these two meet somewhere. It takes this much time. We found the time sitting on B's frame. You can find the time sitting on A's frame as well. But here I used B. This is the B frame. B is at rest. Okay. Okay. Now I know the time. I'm going to jump back to the Earth frame again because they are asking something about Earth frame. They are asking about A's movement, right? A do a partial movement, but in the B's frame, A does the whole motion. But they are asking something about Earth frame, the amount done by A. So for that, let's say that is X. I'm applying S equals ut. This is X is what they ask. In Earth's frame, velocity of A is just V or U. U, right? Velocity of A is U. And time we found is sitting on B's frame, that is S divided by U plus V. So the answer should be US divided by U plus V. This is X. Yeah, fifth answer. Fifth is the answer. Correct. Fifth answer. Understood? You can take it down. So to explain this, it takes time, right? Okay. You mean this part, right? So you understand how you found time. Time is found sitting on B's frame. Time is the same for any frame, right? It doesn't change depending on the frame. Time is same for any frame. So on the B's frame, B is stopped. A is moving towards B at U plus V. A is moving U plus V. What happens on Earth's frame? In Earth's frame, both are moving. A and B both are moving. what they ask is distance to meeting point. Actually, they meet here, right? What they ask is distance to this meeting point from A. So that is x. We know for the meeting to happen, the time is s divided by u plus v. In Earth's frame, velocity of A is u. Then u times time we found using the B's frame, should be the Earth frame distance to the meeting point. Understood? So we jump back and forth between Earth and B frame. Using B frame, I found time. Then back to Earth frame, because they are asking something about Earth frame, right? I think you understood. So you have to think about this further and further, right? The more you think about this, the clearer it gets. Okay. Somewhat you might be some way confused, because for some students this might be like a bit confusing, but it will be clearer. You have to think about this again and again, right? So these are very important concepts. Okay, then try ninth question. Question 9. Is the board clear now? Still the board not clear? Okay, try ninth question. First draw is sketch, okay? Draw the sketch, Earth sketch, Earth frame. Right, let's see. Now there are 3 objects moving, right? 3 objects moving. Trains, and there's a bird as well. So here what happens is, this is Earth frame, right? This is Earth frame. Train A is moving to this side, B is moving and meets somewhere here. Trains meet somewhere here. You don't have to draw trains, right? Just put points there. Because they haven't mentioned lengths of trains, you can just put points there. So these trains would meet somewhere here. So meanwhile these are moving towards each other, a bird is moving back and forth between these 2 trains. A bird. So you just have to find the distance, the total distance that bird has traveled between those 2 trains. So you know, within a time simple t, till these trains move, till these trains meet, birds keep traveling at 50 kilometers. So here you have to find the time required for these 2 trains to meet, right? How do we do that? Actually, now I'll stop one of the trains. Let's say I stop B. So everything should be relative to B. So velocity of A relative to B. Moving to opposite directions, 40 plus 20. 60. What's the direction? You don't have to think all these, right? I'm just explaining this. If B is stopped, A is moving to this side at 60 kilometers. So how do you draw the B frame? B is at rest. A is moving towards B at 60 kilometers per hour. So that is seen by B, right? And the gap is 120. So whole gap 120 is done by A. Then just apply sequentiality. 120 is the speed, relative velocity is 60. So the time is 120 divided by 60, that is 2 hours. So it takes 2 hours to meet these trains. So I found this in B's frame. To do this, you didn't have to write all these, right? You can just divide 120 by 60. You can do this in your mind as well, right? But for essay questions, you have to do this. Okay? That's why I'm explaining this. So time is 2 hours. So within these 2 hours, the bird keeps moving. So to bird, then just think about a bird. This is Earth frame. Distance traveled by a bird. Speed of the bird is 50 times 2. So it is 100 kilometers. Yeah, answer is correct. Yeah, second answer, right? 100 kilometers. I think everyone understood. Take this down, and if you didn't, if you have any problem, please let me know and try 10th question. So in the 10th question, the lengths of the trains are given, right? Lengths of trains are given. So you cannot draw points for trains, right? You have to include the lengths. Draw a sketch for that first. 10th question. Did everyone taken this down, or thumbs up, right, if you've taken it down? Okay, draw a sketch for 10th question. 10th question. Right. So the sketch goes like this. Sketch goes like this, right? So there are two trains. So train A, train B. So these types of questions you must, you should, right? You should use relative motion. Otherwise, these questions are hard to imagine to do at Earth's frame, right? So you have to go for relative motion for a question like this. So train A moving at 20 meters per second, B moving at 30 meters per second. This is Earth, right? Earth frame. Everything relative to Earth. And lengths of these trains are given as one is 100, another one 150. So this train is lengthy, right? And the gap between them, between the front faces of them, is 50 meters. So what they ask is time to pass these. How do we do this? In this case, it is somewhat difficult to do this question in Earth's frame. If you stop one of the trains, then you have to think about other train only. Then the question gets somewhat easy, right? I'll stop B. So I need to solve this problem sitting on B's frame. Let's see what happens. Now just think B is stopped, right? First, let's find relative velocity. Relative to B, velocity of A should be what? Moving to opposite directions, so it should be the sum. So that is 50 meters per second. So this is B frame, right? B frame. Now the train B is completely stopped and its length is 150 meters. There's a 50 meter. And what about train A? So this is B frame, right? This is earth frame. This is B frame. B is stopped. B is stopped. Train A is having a 50 meters per second velocity now. Got it? Only train A is moving. Train B is stopped. So in order to pass train B, you have to think how much of a distance does A has to move. Only A has to move. First think about this front, right? This front of the A. It has to do 50 meters. Then another 150 meters. So the arrangement would be like this. So this front has to do 50 meters, then 150 meters. So it is 200 meters for now. Still it is not passed. Train B is not passed. In order to pass, A has to move to this another 100 meters. So A has to do 300 meters of distance. Did you understand that? 50 meters, 150 meters, 200 meters. And the arrangement of A would be like this. Then it has to pass its length as well out of B. So 200 plus 100, 300 meters. Did you understand 300 meters? A has to move 300 meters to pass train B. So that is what passing means, right? These ends should be away, should be apart at this instant. So relative to B, A has to do, relative to B means if B is stopped, A has to do a displacement of how much? 300 meters. Now you have to find the time. Now apply S equals ut. This is B frame, right? So SAB is 300. What is VAB velocity? 50. And time. So the time is 300 divided by 56 seconds. It takes 6 seconds. Understood that. Take it down. Take it down. If you have any problem, let me know, right? This one you must understand completely, 100%, right? In a case like this, it is hard to think about both moving. So we stop one, right? Then you have to think only about one thing, one object. Thumbs up, right, if you've taken it down. Right. So up to here, if you are clearly understood, you have a good understanding of relative motion, right? Right. Then the next part of relative motion, that is inside or on a frame. First, so these are different types of questions, right? These are different types. Here, all these velocities are relative to Earth velocities. But the questions after this is not going to relative to Earth. Some velocities are relative to Earth, some are not, right? Therefore, you have to go for the fundamental equation, the basic equation, earlier equation. When we are first start doing the questions, not questions, I mean, start of the lesson, you can just try the question and draw a sketch or something. Try 11th question. 11th question. These are different types of questions, right? 11th. So when they say inside the train, what does it mean? Inside the train means relative to. Inside also means relative, right? Inside a train or on a bus, not on a bus, on a boat. Whenever they say something like that, it means relative to that thing, right? Inside the train means relative to the train. Got it? Take passenger as P, train as T, earth as E. So here you have the train. Train is moving 25 meters per second. Obviously, it is just velocity. So it is, yeah, we'll see. This is relative to Earth, right? Relative to Earth, velocity of the train is 25 meters per second. The train's velocity is obviously relative to Earth. Okay? A passenger moves inside the train, meaning relative to the train. This is not related to Earth, right? This is relative to train. So how do you write? Relative to train, speed of passenger. Relative to train, speed of passenger. So in this case, you cannot apply V1 plus V2 or V minus V2. Those are applied for Earth relative. If everything is Earth relative, you can apply those. But for this, you cannot. So you have to go for the fundamental, right? What do they ask? Velocity of passenger relative to Earth. This is what they ask. Relative to Earth, velocity of passenger. Put third object in between. What do you get? VPT plus VTE. Understood? TT in between, right? So what is VPT? Substitute with the directions to this side. Plus VTE 25 to this direction. So to simplify, everything should be to the same direction. Flip the direction and it becomes -1 plus 25 this direction. So to the same side, what do you get? -1 plus 25, what do you get? 24 to this direction. So relative to Earth, passenger moves 24 meters per second. Yeah, the correct answer, 24. You cannot apply the previous theory, right? You cannot just add these and get the velocity, because this is a different scenario now. So for this, you have to consider the fundamental equation. Take it down. Thumbs up, right, if you're taking it down. Everyone understood that, right? No confusions? Okay? No confusions, okay? So let's see actually what does this mean. So within a second, right? Within a second, train moves 25 meters. Then relative to the train, passenger moves 1 meters back. So relative to Earth, how much distance the passenger has moved? So with the train, passenger does 25 meters, right? With the train, passenger does 25 meters. But since he is moving inside the train backwards, 1 meter, After 1 second, where does the passenger ends up? Passenger ends up 24 meters relative to the earth. Understood, right? With the train per second, passenger does 25 meters. But since the passenger inside the train moves backwards, 1 meter. So what's the total distance? Relative to earth. Relative to earth, passenger has done 24 meters within a second. Understood? So you have to understand, depending on the depending on the observer, the displacements and velocities changes, right? So for relative to earth, it is 24. Relative to train, someone inside the train sees passenger move backward 1 meters per second. Someone on the ground or someone on earth sees passenger does 24 meters. Right? So depending where you are observing the object, another motion of object, you see different values, right? Different values. So you have to understand these velocities and displacements and everything is relative to you, relative to the observer. You have to understand, right? It is always relative to observer. Then try 13th question. 12 is the same, right? It is mistakenly same. Try 13th question. 13. Yeah, if the passenger is inside the train, obviously the passenger should be inside the train, right? If the passenger is inside the train, let's say another passenger inside the train at rest. So he notices 1 meters per second inside the train. Someone on the ground sees the speed of the passenger as 24 meters per second. Someone inside the train sees the speed of the passenger as 1 meters per second. Got it? You can imagine that you are on a train, right? Let's say someone is moving on the train. What you see is his velocity. These are very practical scenarios, right? Very practical scenarios. You have to think about these. Like when you are moving on a bus or a car or a vehicle, you have to think about these, right? You have to apply relative motion concepts there, right? When you are so you have to constantly think about these, then these gets clearer, right? That's why we learn physics. Okay, you can apply those day to day. Okay, 13th question, draw a sketch. So train is moving 30 meters per second. It is relative to earth. So someone inside the train throws a ball to this direction. Okay, let's see. Throws the ball at 60 meters per second. What is this 60 meters per second? Inside the train, right? Meaning relative to train. Ball. B's ball. So what they ask is velocity of ball relative to earth. So bt plus vte. Bt is substitute with the directions. Bt is 16 upwards, te to this side 30. So we have vectors, two vectors, then do a vector calculation. So 30 to this side, 16 to this side. Draw a rectangle, find the length of the diagonal. What's the diagonal? That's going to be VBE, right? So apply Pythagoras, 30 and 16. What's the 30 squared plus 16 squared root 30 squared 900, 16 squared 256 root 56 11 1156 root 34. Yeah, when you take the root, it gets 34 meters per second. Third answer. Take that down. If you have a problem, let me know. Third answer. Those who did that question, you can do try 14th question. Yeah, third is the answer. Yeah, you can try 14th. That's a similar question. 14th. If you have problems, let me know. Right. The answer is not given there, right? The answers are not changed there. Did you get 10 meters per? What did you get? 100 meters per second or something? Not 100. 900 plus 100. You get 1000 root, right? 1000 root. Yeah, the answer is not there. Okay. The answer should be 1000 root. It is a same case like this. Then try a 20th question. 20th question. Yeah. The answer is not there. Okay. The previous answers were copied down. Was that the problem there? Try 20th one. So this is north. This is east. An airplane flies 300 kilometers east. In still air means what does it mean? In still air, whenever still means at rest, right? Whenever something is at rest, what does it mean? Relative to that. So this velocity is relative to air. This air, I'll say wind, right? Capital W. Air. So air and wind, same thing, right? So I'll use W there to express that. So those terms you have to understand. 300 kilometers per hour, velocity of airplane, capital A, relative to wind. In still air means whenever you say in still water, let's say not air, let's say still water, this has this velocity, meaning it is relative to wind here. If it is water, it is relative to water, velocity of this one, that is 300 kilometers, and he is moving to east. And it encounters a wind blowing from north, not towards north, it is from north. Velocity of wind is relative to earth, right? From north, 50 kilometers per hour. So what they ask is airplane relative to earth. Put W in between. VAW plus VWE. So substitute with the directions, 300 to this side, 50 to this side, right? Then you just have to add these two. Draw a rectangle, 350. So the relative velocities to this side. So you have to find this. So apply Pythagoras, 300 squared, 50 squared, root of that. Take 50 squared out, you get 50. Inside 36 and 37. 37 is closer to 36, right? So 6 means it should be a bit larger than 6. So you get 300, it should be slightly larger than 300, right? So you can see the answer, you don't have to simplify that. You can see answer should be around 304. You don't have to completely simplify this, right? Yeah, answer should be third one. We'll do one more question, okay? We'll do one more question. Try 18th question. Try 18th. In static water means still water, right? In static means relative to water. That's what it means. Static also means still. Take it down. Take this down. Then 36 root means 6 point something, right? Because 36 means 6 when you take the root. Did you understand? 36 should be slightly larger than 6. I don't know whether you understood that. Did you understand up to here? Okay, simplification part, right? So this 300 is squared, I can write this as 50 squared times 6 squared plus 50 squared. Understood? 300 can be written as 50 times 6. Square is applied for 50 and I think 6 squared. 300 can be write like 50 times 6. Then from these two terms, take 50 squared out. What do you get? You get 50. So inside it remains 6 squared, which is 36. Then this 50 squared, you taken it out, remains 1. So 36 plus 1 is 37. Understood? Okay. So 37, you don't have to find 37, root 37. You know 37 should be slightly larger than 6, right? So the answer should be 304. Try 18th question. Okay, right. Try 18th. Did I say 18 or 19? 18, 18th, right? Both are similar questions. First draw the sketch 18th. So I'm doing 18th, right? So you have a river and river is flowing at 3 meters per second. It is obviously relative to, here river means water, right? Water is flowing. So I'm putting W here. W means water, right? Or the river. This is relative to earth. And the width is given as 300 meters. So boat is traveled at still air. Sorry, not air. Still water, right? Static water. So relative to water, speed of boat. So that's what it means. If they say still air, it means relative to air. If they say still water, it means relative to water. Relative to water, boat speed is 4 meters per second. And it is perpendicular, meaning to this direction. So we have this. Yeah, whenever they say speed of the boat in static water or still water, meaning of that is, you can directly use that, right? Meaning of that, relative to water, that speed is relative to water, not relative to earth, it is relative to water. It is same as before. They, for the previous case, they said still air. Understood? Still air means relative to air. Air or wind there, right? Understood? Directly take like that, right? You would get the answer there. If it is still water, you can directly consider that velocity is relative to that water. You can directly take it. Not related to earth, right? Yeah, relative to earth means capital E. This is what they ask. So what is that? VBT plus VTE. BT we found somewhere, not BT, BW, right? Here we have water. BW is 4 upwards. W is 3 to this side. Then you need to take actually they are not asking about so what happens is the boat is trying to move like this, but due to the motion of the river, boat moves something like this. This is relative to earth, right? Relative to earth, boat travels like this. But relative to water, boat is trying to move like this. But actually what happens is boat is moving like this. So it is VBE, this one. This is VBW. They can move the boat. If water is still, you can move the boat perpendicular to the river. But river is obviously flowing, right? So the boat would travel like this. Understood? I don't know what you're asking. Is that what you're asking? Right. You can find this in W's frame as well. W's frame. Okay, let's find to find the time. You know that when the boat is moving from here to here, this component also moves from here to here. So you can consider only this one to find the time. So you just apply S equals UT to this side. So the distance is 300. BW is 4. So the time is what? 300 divided by 4. What do you get? 150, 75 seconds. So it takes 75 seconds. Not 60 seconds. It is 75 seconds, okay? In order to find the time, you don't have to think about this. You can find the time going through this as well, but to find the time, you can think about this. Sitting on W's frame, water's frame. Did you get 75? So here what happens is, this X is what they ask, this distance. The boat is dragged along the river, X distance. How do we find the X distance? It is easy, right? So to this direction, boat is moving at 3 meters per second. To this direction, boat is moving at the speed of the river, water. It is moving with the water, right? So what should happen to X? X is equal to, for the river 3, the time 75. 75 times 3. 225. So this distance is 225. So along the river, the boat is dragged 225 distance. If anyone have problem, let me know and take it down, right? Thumbs up, right, if you are taking it down. I did 18th question, right? 18th. This question is 18, right? Not 19th. Did just take it down, right? Thumbs up if you are taking it down. Do anyone have problems? Yeah, this is the last question here, right? Do anyone have problems? So else we can wind up the lesson here. Thumbs up, right, if anyone don't have problems regarding this question. Right. So there are a few questions remaining. You can do those questions by yourself, right? By yourself, you can do those questions. There's a test at the common group common group at 2025. That test also contains, I think, test number 5, right? Test number 5 in the common group. Relative motion questions. If you haven't done that test, you can try that, and you can enhance your knowledge on relative motion further, right? I think now you have a deep understanding of relative motion. So here we up to now we have talked about relative motion and projectile motion, then relative motion. So now you have if you clearly follows through this, you have a excellent understanding and deep understanding of these concepts. So the next part we are talking about Newton laws, right? From this next chapter we are talking about Newton laws. So from Newton laws we'll be talking about Newton laws, rate of change of momentum, momentum conservation laws, about collisions, about forces, action reaction forces, free body diagrams, those stuff. Yeah, right, those stuff, right? Yeah, the projectiles homeworks given, right? Okay, so that is the next chapter, right? So to further enhance this relative motion, you can try test number 5. I'll enable, if you just send me a message if you want to do that test again, test number 5. It is on the common group. So in the for the next classes, you have to again register for the next classes and do the necessary payments and register for the next classes. So we'll be doing Newton laws, right? Basically Newton laws. That is momentum, basically rate of change of momentum, conservation laws, collision types, free body diagrams, all those things. So we'll be doing that within this month. Till the end of this month, we'll be totally focused on Newton laws. Okay, so you will have excellent knowledge on Newton laws. So you have to, you have to register for that next month, right? I'll send the register forms on the group as well. So if you have any problems, you can send me messages. Then we'll wind up the class for this session, right? Right. Then good night, everyone. Right.